Okay, class, welcome back. I hope you guys enjoyed your first week of online schooling. Now today we are starting week 2. And today with that we are starting day 5, permutations of identical items. And with the objective today, we're finding the number of permutations for a set with identical items. This is just kind of branch off of what we learned in the previous week. So it's just going to keep building off of one another. For our warm-up today, Miss Harrod is planting a row of 3 flowers. 2 of the flowers are red roses, and the other is a yellow tulip. List the 3 ways that the flowers can be arranged in a row. So to do that, I'm going to first get my pen up here. So we have 2 red, and then we have yellow tulips. Well, 1 yellow tulip. So we could either arrange it as a red rose, and then yellow tulip. We could have a red rose, yellow tulip, and another red rose. What's another way? Let's think. We could have the yellow come first, the yellow tulip, and then the 2 red roses. Looks like those are our only 3 ways here, because if you were to, this is going to be kind of similar to what we learned last week with permutations. We were to have these 2 sets here, but if this was rows number 1 and rows number 2, and if we started off this next row here with rows number 2 and rows number 1, those red roses are identical, so you cannot tell them apart. So that order, this set here and this set of roses or set of flowers here, they are the same, so they're not different. So that's why we only have these 3 options. It just counts as one way down in this down here. So let's go and do some different ways of arranging letters in words. We did it again. We kind of briefly touched on this last week, but we're going to go into more depth with it today. It's asking how many different ways can you arrange the letters in the word food. Again, they don't have to spell out the actual word, like it can be non-English. So let's just start by listing them off here. So one of them is the obvious, food, because that's what we were given. That's one of the ways. You can have F-O-D-O. You can have F-D-O-O. And I think those are all the different ways to start with F. Let's try starting with D. We're going to have D-F-O-O, D-O-F-O, and D-O-O-F. Okay. Now we got to come up with the ways of arranging O first. We're going to have O-O-F-D, O-O-D-F, O-F-D-O, O-F-O-D. Again, the way I'm writing these in order, there's no particular order. I'm just kind of going through and writing down all the options we can come up with here to help us find an easier way of doing it. We have O-D-O-F. I think there's only one more. I think it's O-D-F. Oh, yeah, I don't see that we've done that one yet. So if we count them all up, looks like there's 12 different ways here we can arrange those letters. And another way, if you, this was just one way you can count them all off is by listing them off. But when we're dealing with letters that have more than 4 or 5 letters, you're not going to want to list them all off. So we're going to do this instead. You're going to take your total letters, and in this case, I'm going to write it up here. We had 4 total letters. 4 total. And then you're going to take your total letters and divide it by the amount of repeats. And what in this one, since we had 4, so we're having 4 factorial, stay on their top because that's our number of total letters. Now at the bottom, our denominator, the amount of repeats. I just draw arrows connecting them. We have one letter that repeats, but we have it twice. So we're just going to say the one letter, 2 of the one letter, so 2 factorial, because there's 2 of it. If there was 3, let's say it was F-O-O-O-D, let's say it was 3 O's, then it would be 3 factorial instead on the bottom. So again, there's 4 letters in food, and there's 2 O's in food. Now that we know this little handy dandy thing right here, we're going to apply that to problems to come. Okay, so it's asking similar, let's slide that down. Same problem again, where it's saying how many different ways can you arrange the letters in the words listed below? Again, we're not spelling out actual words here, so let's count out. Remember how it's a total over repeats. Okay, so how many total letters are in the word beetle? Let's count, shall we? 1, 2, 3, 4, 5, 6. So we have 6 factorial in the numerator over, looks like we just have one letter that's being repeated, but it's being repeated 3 times. So that's 3 factorial. And that equates to 6 times 5 times 4 times 2 times 1, that's 6 factorial, over 3 factorial. And again, remember those cancel out, as they would equal 1. So you're left with 120, because that's what 6 times 5 times 4 equals. Now for our second one, we have pumpkin. Again, let's count out how many total letters. 1, 2, 3, 6, 7. 7 factorial over, let's see, what letters we have repeating. It looks like we just have 2 P's. So that's going to go on the denominator as 2 factorial, because there's 2 of them. So now we have, and again, the little shortcut is 7 minus 2 is 5. So we're going to write down the first 5 letters, or 5 numbers of 7 factorial. So it's 7 times 6 times 5 times 4 times 3. Because the 2 and the 1 would cancel out, that equals 3,520 different ways. Oh, that's quite a... See, again, now you know why we do this here. So we don't have to write all these different ways out. Now, last but not least, we have the word river. Oh, no, there's one more underneath it. River, then Mississippi. So for river, again, we have 5 different letters. Well, 5 letters total, I mean. And then it looks like we're just repeating the R. So 5 factorial over 2 factorial, because there's 2 R's. So we have 5 times 4 times 3, which you can see it is 60. So we know that there's 60 different ways of arranging the letters in the word river. Last but not least, oh, this is a big one, Mississippi. First, again, counting out how many total letters are in the word. 1, 2, 3, 4, 7, 8, 9, 10, 11. Wow. Okay. 11 factorial on top. Looks like we have 4 S's, so that's going to be 4 factorial because there's 4 S's. So we got the S's. Looks like there's 4 different I's. So another 4 factorial. I'm just crossing them off so I know I already used them. And it looks like there's only one other letter that's repeating, the P's. There's 2 P's, so that's 2 factorial. And again, so let's see what that is going to equal out to. For the sake of time, I'm just going to leave it as this. But I want you guys to go through and finish solving it with a calculator. Ooh, okay, so here's our challenge problem. How many different ways can 3 pennies and 2 quarters be arranged? Okay. So again, let's think of our total coins. We have our 3 pennies, Now 2/4, and 3 plus 2 equals 5. So we know that that's our total. So we know that's going to be our numerator. So we have 5 factorial in the numerator. Now we'll think of our repeats. Well, we have 3 pennies, so we have 3 factorial because there's 3 of those. And we have two separate quarters. So there's a repeat or identical item of 2/4, so times 2 factorial. So now if we write that out, we have 5 times 4 times 3 times 2 times 1 is 5 factorial over 3 times 2 times 1. 3 factorial is right there. Then we have 2 times 1. And I'm going to cancel these guys out because they're going to be the same. So then we're left with 20 over 2, because 5 times 4 is 20. 2 times 1 is 2. And 20 over 2 is just 10. So we know there's 10 different ways to arrange those 3 pennies and 2/4 that would make them different and unique. So with that said, I hope you guys were able to get a better understanding as to how to go about finding permutations with identical items. If you have any questions, feel free to email. And your homework and homework quiz are posted on Schoology. Make sure you guys are continuously going and checking Schoology for any updates that I might post on the main page, or check your email as well. Since this is online school, it's a little easier to get kind of behind and not have yourself be as accountable as you would in school with us reminding you. So with that said, hope you guys enjoy today's lesson and have fun.